So let's write down the remaining constants. Now so far what we have used X bags of brand P, Y bags of brand Q to be used with the objective function to minimize the cost, which is represented by Z, which is equals to 250X plus 200Y. So we have already covered the cost column. Now let's write for the nutrient A. What the table says, 1 unit of brand P need 3 units of nutrient A. So 1 item of brand P, or I can say 1 item of brand P needs 3 units of A. So how many bags of brand P we are going to buy? X bags. So X bags of brand P need 3X quantity of nutrient A. Now nutrient A is present in both brands, brand P and brand Q. So now we have to use this constant as well, this number as well. So one bag of brand Q need 1.5 units of nutrient A. So Y bags of brand Q need 1.5 times Y units of nutrient A. Now what is the total nutrient A will become? This is the required by P and required in bag Q. So which is 3X for bag P and 1.5Y for bag Q. Now what is the minimum requirement of nutrient A? Minimum requirement for nutrient A is 18. So 18 is minimum requirement. So minimum means it can be 18 or it can be more than 18, and we can combine it to write greater than or equal to. So we say that the constant for nutrient A, the constant become 3x plus 1.5y is greater than or equal to 18. So we will write down this constant here, 3x plus 1.5y is greater than or equal to 18. Okay, let's remove it from here. Now let's work on second constant corresponding to nutrient B. Now working in the same way, one bag of brand B required 2.5 units of one bag of brand B required 2.5 units of nutrient B. So X bags will require 2.5 X units of nutrient B. Similarly, one bag of brand Q required 11.25 units of nutrient B. So Y bags required 11.25 Y units of nutrient B. So what will be the total nutrients for A? Total nutrients required in B is the requirement coming from P and from Q. So this is from P, 2.5. So this is 2.5x plus from Y it is 11.25y. Okay. Now how much is the minimum requirement? 45. Since again it's a minimum, so it should be greater than or equal to. So our constant here become 2.5x plus 11.25y greater than or equal to 45. Let's write down it over here. So the second constant is 2.5x plus 11.25y greater than equal to 45. Now we will work for the third constant for nutrient C. Working in the same way, one bag of brand P need 2 units of nutrient C. So one bag of P require 2 units of nutrient C. So X bags required 2x units. Similarly, one bag of Newton Q require how many units of C? Q for C is 3. How many bags of Q we are producing? Y. So Y bags required 3Y. So what will be the total requirement for C? It becomes from P, which is 2X, and from Q, which is 3Y. Again, what is the minimum requirement? 24. So as it is 24, so it should be 2X plus 3Y greater than or equal to 24. So we'll write the constant over here. 2X plus 3Y greater than equal to 24. So now we can see that we have used all the numbers. 3, 1.5 in the first quadrant, constant and 18 also. Here we have used 2.5, 11.25 and 45 while writing the second constant, and 2, 3, 24 while writing down the third constant. So it means we have optimally used all the parameters. We have the objective function, we have the constraints. Okay, now as we said that we are going to buy X bags of brand P, Y bags of brand Q. So either we buy some bags or no bags. So this gives us the non-negativity restriction that X will be greater than or equal to 0. Means either we buy no bag of brand P or we buy one bag, two bag, and so on. It cannot be negative. Similarly, for Y it can be either greater than or equal to 0. So we will write this additional constant over here. We can combine these two together and write X and Y greater than equal to 0. So this becomes our formulation of linear programming problem. So how is it? Objective function is minimizing the cost, which is represented by Z equal to 250x plus 200y, subject to the three constants for each nutrients A, B and C with non-negativity restriction that X and Y should be greater than equal to 0.